Hello my dear students and friends. Today in this video I'm going to revise about carboxylic acids, which is in the chapter aldehydes, ketones and carboxylic acids. Okay, first of all, carboxylic acid is represented by this structure RCOOH, and we have some derivatives of carboxylic acid as well. This is carboxylic acid, and if this OH is replaced by OR, then the compound is called ester. And if this RC double bond O, okay, if this OH is replaced by X, some halogen, then this will be called as acyl halide. Okay, and if this RCO, okay, OH is replaced by NH2, then a compound is called acid amide, right? And if this OH is replaced by OC double bond OR, these two are can be same or different, then a compound would be called as anhydride or acid anhydride, right? So these four compounds are called derivatives of carboxylic acid. Okay, these four compounds are called derivatives of carboxylic acids. Okay. Now next topic is IUPAC name. IUPAC name of carboxylic acid. Carboxylic acids are named as alkanoic acid. Alkane, after removing E of alkanoic acids. This is the IUPAC name, or alkane carboxylic acids. Carboxylic acids means suffix of carboxylic acid is oic acid or carboxylic acid. This oic acid is used when the carbon of carbonyl carbon atom, this carbon, not carbonyl, I guess this is carbonyl actually, but this is not considered as carbonyl. When this C is counted in numbering as 1, then oic acid is used, and if this C is not counted in numbering, then carboxylic acid is used. For example, let me give some example. The first one is CH3COOH. Now in the carbon chain we have two carbon atoms, so we name this carbon atom as alkane, means ethane. After removing E, I am going to add oic acid, so this carboxylic acid is called ethanoic acid. Now in the second example, if I write this, then this carbon is to be included in numbering 1. Numbering is to be started from this carbon atom, okay, 1 2 3 4, and this OH as a side chain or substituent which is attached to the third carbon of the main chain, so this is to be numbered as 3 hydroxy. We have 4 carbon atoms in main chain, so but is the word root, N is the primary suffix, then oic acid is to be added, right? So this is the prefix, this is the word root, this is the primary suffix, and oic acid is our secondary suffix for the principal functional group. Okay, now let us move to the third example. If I draw this structure, and This is to be named in IUPAC system. Then this is our principal functional group, and this carbon atom is not numbered as 1 in this case, because this is outside the chain, and this carbon atom to which this COH is attached is to be numbered as 1, and this is 2. So this carbon is not counted in numbering. So in such cases we are going to use carboxylic acid as the suffix, not oic acid. Okay, so let me write this compound. The name, IUPAC name of this compound is 2-methyl 2-methyl is the prefix, and the chain is cyclic in nature, so I'm going to add cyclo, 2-methyl cyclo. Then we have 5 carbon atoms in the main chain, so pent N. Now after A and E, which is the primary suffix, I'm going to add carboxylic acid, not oic acid, carboxylic acid. So this is the IUPAC name of this compound. 2-methyl is the prefix, cyclo is for the cyclic nature of the chain, pent is the word root, An is the primary suffix, carboxylic acid is the secondary suffix. Okay. In the next example, I'm giving this compound. This is a compound in which we have 3 carboxylic group attached to 3 different carbon atoms. So this is to be named. Now for naming this compound, we must shorten the chain like this, because if I choose the chain like this, then 5 carbon atoms will be in the main chain, but this COH will be side chain, while this 2 COOH will be included in the main chain. So to give equal priority to the 3 functional groups, we shorten the main chain. So this is 1, 2, 3. So this C is not counted in numbering, but still these are our principal functional group. So this is to be named as propane 1, 2, 3 tri carboxylic acid. Okay, propane 1, 2, 3 tricarboxylic acid. So in this name, prop is the word root, there is no side chain here. ANE is the primary suffix, and carboxylic acid, tricarboxylic acid is our principal this is the secondary suffix of the principal functional group, right? Okay, now let us move to the next example. This is our benzoic acid, or benzene carboxylic acid, I can say. This is our benzoic acid, and if I ask you to name this compound in IUPAC system, then this is to be named like this. This is 1 and this is 2. So we have benzene dash 1, 2 dicarboxylic acid, dicarboxylic acid. Okay, we cannot say benzene 1, 2 dioic acid. Oic acid is used when this carbon atom is numbered as 1. Okay, this is also called phthalic acid in common name. Okay, now let us move to the next topic, which is preparation of carboxylic acid. Preparation. Okay, the first preparation of carboxylic acid is from nitriles. By hydrolysis. Okay, so when this carboxylic acid, when this alkane nitrile is hydrolyzed in presence of an acid or base, then this is hydrolyzed to RCOOH. This is our carboxylic acid. So let me give one example. This is our propane nitrile, and if it is hydrolyzed in presence of an acid or base, then this is this from this compound, after hydrolysis in presence of an acid or base, we are going to get CH3 CH2 COOH. Okay, only this CN is hydrolyzed to converted to COOH. So IUPAC name of this compound is 1, 2, 3. We have 3 carbon atoms in the main chain, so it is to be named as propane nitrile, right? And this is our propanoic acid. Okay, let us move to the second preparation, which is from alkyl benzenes by oxidation. Okay, when alkyl benzene containing at least one benzyl carbon atom, the alkyl benzene must contain one benzyl carbon atom, then only oxidation will take place. This is our methyl benzene, which is also called as toluene. This is our ethyl benzene. Okay, when this methyl benzene or ethyl benzene is reacted with KMnO4 in presence of a base followed by acidic hydrolysis H3O plus, then this is oxidized to benzoic acid. This alkyl benzene also contain one benzyl hydrogen, 2 benzyl hydrogens here. Actually, we need only one benzyl hydrogen for oxidation to occur. When this is oxidized with KMnO4 followed by acidic hydrolysis, then this is also oxidized to benzoic acid. We only obtain benzoic acid irrespective of the nature of the alkyl group, but the condition is there must be one benzyl hydrogen. Okay, rest if 5 carbon atoms are here in the alkyl side chain, then also the 4 carbon atoms will be oxidized to carbon dioxide. Okay, this benzyl carbon atom will be converted to benzoic acid. Okay, next let us move to the third preparation of carboxylic acid, which is from amides. Okay, from amides by hydrolysis. So this is our amide, acid amide. When it is reacted with water and if it is heated, then the reaction undergoes simply removal of ammonia to form this RC double bond OH plus ammonia plus NH3. NH3 will be byproduct. Okay, this is our amide, and let me give one example here. Simple example. I'm just giving this amide. This is called ethane amide. Okay, and this ethane amide is heated with water then NH3 goes out to form CH3 C double bond O OH plus NH3. So this is our ethanoic acid. Okay, I can give one more example. This is our amide, and if it is reacted with water, 2 moles of water, and heated, then 2 moles of water, okay, then heated, then we will get this. This will be our phthalic acid, benzene 1,2-dicarboxylic acid. Okay, now let us move to the third preparation of carboxylic acid, fourth. Okay, this is from alcohols and aldehydes by oxidation. Okay, when a primary alcohol, we must take a primary alcohol, we cannot take secondary or tertiary alcohol here, and if it is reacted with KMnO4, which is usually taken with a base, but the reaction mixture has to undergo acidic hydrolysis, then this CH2, this CH2 is converted into CO, which remains same. This CH2 is just converted into CO. So this primary alcohol is converted into carboxylic acid. Okay, I can give one example here. Similarly, okay, let me give the example first. CH3 CH2OH, and if it is reacted with KMnO4 followed by acidic hydrolysis, then we will get this CH2. After converting to CO, ethanoic acid will be obtained. Sorry, here only CH2 is converted into CO. Okay, this is our ethanol and this is our ethanoic acid. Now when I take an aldehyde here, and if it is reacted with KMnO4, like this, then also we will get carboxylic acid. This is also oxidation, addition of oxygen. So again, let me give one example here. This is our benzene, and if there is CH2OH and the CHO here, and if it is reacted with KMnO4 with the base followed by acidic hydrolysis, sorry, this is our acidic hydrolysis, then we will obtain this product. This primary alcohol will also be oxidized to carboxylic acid, and this aldehyde is also oxidized to carboxylic acid. I can give one more example here, which has been asked in the council exam class 12, and the reaction goes like this. This is our 2-methyl benzaldehyde, and if it is reacted with KMnO4 with an acid, KMnO4 with a base followed by acidic hydrolysis. Okay, then what will we get? The answer is very simple, because this ethyl group is also easily oxidized to benzoic acid like this, and this CHO will also be oxidized to carboxylic acid. So we will get this phthalic acid again. Okay, now let us move to the fifth preparation of carboxylic acid, which is from acid halide by hydrolysis. I am taking one acid halide here, RCOCl. Okay, this is acyl chloride, and if it is reacted with water, then HCl goes out very easily, because this acyl halide is very reactive, like this simply. Okay, then we will obtain RCOOH plus HCl. Okay, like this. So I'm giving here one example: CH3 CH2 C11OCl, and if it is reacted with water, then HCl goes out to form CH3 CH2 C11OOH with HCl. This compound is named as 1, 2, 3 carbon atoms are there, so this is named as propane. After removing E and adding oil chloride, so we obtain propanoyl chloride. No, this IUPAC name of this compound is propanoyl chloride, and we obtain propanoic acid. Propanoic acid. Okay, the next preparation of carboxylic acid, which is I think last. One reaction is also left. Okay, the next preparation is from ester. So ester again by hydrolysis. I am taking an ester here, RCOOR. These two R's can be same or different, so I am giving dash over here. And if it is reacted with water, this is our water, and if basic hydrolysis is done, OH minus ion, okay, then we will get a carboxylate ion along with alcohol. This bond is broken, so we obtain RC double bond O. This OH will be attached here. This goes like this actually. Okay, RCO is attached to OH, but since the medium is basic in nature, so we will get this carboxylate ion along with this R dash OH. This is to be again hydrolyzed in presence of an acid, so that we obtain this carboxylic acid along with alcohol. Okay, so let me give one example here. This is the ester, for example. Okay, I'm giving methyl here. I'm taking the two alkyl groups same here, and if it is reacted with water in presence of a base, and if that products are hydrolyzed in presence of an acid like this, then we can directly write the carboxylic acid here, this one, CH3C double bond O OH and plus methanol. These two products will be obtained. Okay, next preparation is from acid anhydride by again hydrolysis. So this is the structure of acid anhydride. Again, these two R's can be same or different, okay? And if it is reacted with water in presence of an acid, this bond or this bond is broken depending upon the nature of the two alkyl groups. Suppose this is broken and this is also broken like this, so this goes out. So I will get RCO to this CO, this OH will be attached like this, plus there will be another carboxylic acid, this one, okay. So we will get a mixture of two carboxylic acids which may be same or different, okay. Let me give one example here. This is our acid anhydride, CH3C double bond O, O, C double bond O, CH3. This is a symmetrical anhydride, and if it is reacted with water in presence of an acid, this bond or this bond is broken to obtain this carboxylic acid plus this carboxylic acid OH. So exactly these two carboxylic acids are exactly same because these two alkyl groups are same. So I can take an unsymmetrical anhydride here like this. This is now an unsymmetrical anhydride. This is the first example, this is the second example, okay. So if it is reacted with water, then which bond will be broken? That is the question here. Either this bond will be broken or this bond will be broken. So water will attack as a nucleophile in this case, so attacking this carbon atom would be easier in comparison to attacking this carbon atom, because we have a bigger alkyl group in this side, okay. So static hindrance by this larger alkyl group will be more, so the water molecule will not attack here. This will attack this carbon atom, sorry, not this one, I'm sorry, this will attack this carbon atom, not this one, okay. Let me rub this portion, okay. Now this O will attack this carbon atom, so this bond will be broken. This will attack to this carbon atom, so this bond will be broken. So we will get, the products will be same, but we must know which bond is broken, okay. CH3, CH2, C double bond O, O, H plus CH3, C double bond O, OH. So we obtain two carboxylic acids here. This is propanoic acid and this is our ethanoic acid, okay. We get a mixture of propanoic acid and ethanoic acid. So this IUPAC this aldehyde is, this anhydride is named as ethanoic anhydride, since we obtain only ethanoic acid from this hydrolysis. So this is our ethanoic anhydride, right? And this aldehyde is named as, since we obtain ethanoic acid and propanoic acid, see, this anhydride is named as ethanoic propanoic anhydride, okay. Okay, now let me give one more example in this reaction. I can take this anhydride. This anhydride, this is called succinic anhydride, right? And if it is reacted with water in presence of an acid, so we will get this bond broken, so we will get CH2 CH2 C double bond O, C double bond O. Here OH will be attached, here also OH will be attached. So this is our succinic acid. Succinic acid. Okay. The last preparation of carboxylic acid is from Grignard reagent. Grignard reagent by reacting with carbon dioxide. Okay, let me write the reaction here. This is our Grignard reagent, RMgX. This R is partial negative while magnesium is partial positive. When this is reacted with carbon dioxide in presence of dry ether, this R of Grignard reagent will attack this carbon atom as nucleophile. This bond will be broken. So let me break this bond. This bond, okay. So we will get this R C double bond O minus, and if it is hydrolyzed in presence of an acid, this O minus will abstract hydrogen from water to form our carboxylic acid. So let me write one example here. CH3 CH2 MgCl. If it is reacted with carbon dioxide followed by acidic hydrolysis, then we will obtain CH3 CH2 C double bond O OH as the product. This will be our propanoic acid. Okay guys, these are some preparations of carboxylic acid which I tried to cover all the reactions given in the textbook, NCERT textbook. In the next video I am going to cover the chemical and physical properties of carboxylic acid, because if I include that parts then the video would be very long. So in the next video I will cover the remaining part of the carboxylic acid. Okay, for today let me complete here, and if you like this video, please share to your friends who are preparing for their class 12 final exam in this year. And if you are new to the channel, please subscribe the channel so that I get motivation for more videos for you. Thank you.